So I'm building SolGuard. SolGuard is an automated system that submits transactions on the Solana blockchain in the smartest way possible, instead of just sending them and hoping they go through. Normally, when an app sends transaction on Solana, it has to guess how much to pay in fees. There's no good way to know if it actually landed and if it fails. Then when it fails, it just retries blindly without understanding why. But SolGuard fixes this all. It watches the network in real time. It picks the right moment to submit, pays exactly the right fees based on the live market data, confirms whether the transaction landed by listening to the live data stream, and if something fails, an AI agent reads the situation, figures out why it fails, and decides whether to retry, wait, or give up, instead of just trying the same thing over and over again. So let's begin the quick tutorial. So when submitting transaction bundles on Solana via Jito, developers face several friction points. So transaction gets dropped because validators leaders skip slots, block hashes expire under network load, slippage limits are exceeded, or Jito audit tips are too low. The standard system simply fails, forcing users to start over again. But SolGuard help with that. It combines a Yellowstone gRPC slot string, a live network congestion oracle, a Jito tip model, and a AI agent that dynamically classify failures and orchestrate retries. Okay, so let's launch the dashboard UI. Alright, so we are connected. So let's look through our dashboard. Okay, so over here we have our stream status. So it is connected to the Yellowstone gRPC, giving us a sub-millisecond slot update. Then we'll go to the congestion oracle. It evaluates the slot skip rate and process to confirm the latency. When the congestion spike, it scales our Jito tip multiplier. Okay. Then next is our Jito tip floor, right? It fetches the live percentile from Jito every 30 seconds. Over here we have percentile 25, 50, 75, 95, and 99, with the amount of lamp pots in each percentile. Okay, as you can see, it's being fetched at real time. And then we have the active bundles. Yeah, so over here it shows the in-flight transaction attempt with the newest attempt sorted to the top. See more about that when we start testing. Then over here we have our AI agent decision engine. It renders the live typewriters output of the AI diagnosis, but at the end of the day, it's still going to create a JSON file with all the data and the decision logs. Then the system logs, it just tell you if we're connected and what's going on. Yeah, so I believe it's time that our demonstration. So yeah, let's start. PM test trading. Okay, and let's run that. Okay, so our first scenario, our API swap. Okay, all right, so it's submitted. Okay, so scenario 2, it was successful. Scenario 2, our stale quote. Check if that is when it's testing when the block hash gets expired. So it's going to retry. Alright. Confirmed. So this over here. Then when the slippage gets exceeded. Do note the AI agent decision, it tells you what happens. Yeah, this one was aborted, simulation failed. You get confidence level 99%. So yeah, it was not added to our bundle because it failed and was aborted. Then the fourth scenario where the digital leader gets skipped, so it retried. So attempt 2 submitted, and now it's confirmed. And the last one is when fees are too low, and let's see how that plays out. Right. Okay, and that was successful. It's made 2 attempts and it's confirmed. And we just used 20 key lamp pots for the tip, and yeah, successful. That should be about it, honestly. So that this video is not going to be long. I will drop most of the docs and explanation about the stack and technology on the post and on the repo. So thank you guys for watching.